Well, hello. Hi, Dean Laga.
Hello,
How are you? That's a nice avatar.
I'm fine. My buddy drew it, and I was like, okay, it's gonna be my avatar now.
Okay, let's do this. All right, I suspect I'll get through slides and we'll do code examples on Wednesday. I think that's a good break. The main topic here is arrays, which I'm going to say, now you guys have to tell me if I'm wrong here. I'm going to say you guys have all seen arrays in a prior programming class, whether or not you discussed them in detail or not, you've seen them and used them in a piece of code. Is that a true statement?
Yeah, I would say that's true. At least for me.
And if it's not, then I think, hopefully we'll be able to clarify any confusions pretty easily. Let's see, yeah, what the heck. All right, so as usual, the outcomes for the module. At the end of the module, please go back and take a look at them and convince yourself that you've picked them all up. And if you're not comfortable with them, then by all means, ask me or talk about it. Oh, I'm sorry, before I get into the topic. So a bunch of you guys participated in the school survey where they were asking you how the online courses were going. Thank you for responding to that. That's good stuff. Some of the responses were about, do you feel like you were able to communicate with the other students or contact other students? And that was the question that got the most, negative responses. And I agree with that. And I think it's a real issue with online courses. And I'm personally puzzled as to how to fix that and how to give you as good an experience as you would have in a classroom where it's natural for you to talk to the person that you're sitting next to in class. So if you guys have brilliant ideas on that, by all means, share it. I think Dean has the Discord server up, and that's a good place to be and hang out. That seems to generate interaction. And also, I do have, I put these discussions on the page, and the reason that I do that is so that you can ask questions that are visible to other people. And in my naive hope is that students would respond to students' questions there in addition to, myself or Dean or Robert or Michael. And so that's a place for you to have discussions and hopefully even respectful argumentation, not typical online back and forth, but actual, I think this, I think that, or here's how to do this, here's how to do that. Excuse me. I think one thing that slows this down is as human beings, we're really shy about publicly saying that we don't know something or we're having trouble with something. That's a normal, natural human way to behave. And I would argue or encourage you to try to squelch that part of your humanity. And if you're having an issue with something, just go ahead and say it publicly. And if you don't want to talk about this, then by all means, we have your post your pets section, and several people have posted pictures of their pets. So something a little more social. Okay, so if you have really good ideas about how to get group involvement, please let me know. And you can, post them in these. By the way, I'm including this, questions discussion in every module. And if it's a waste of our time and causing a bloat on the website, then you can tell me that too. That maybe I should just have one discussion for everything. And if people want to post questions, they can there. I think Our experience, and Dean will tell me if I'm wrong, our experience is we get further along into the semester, and particularly as you guys get further along in your project, you're going to want to ask questions of each other and of us. And by all means, I think a public forum for that kind of thing would be just the right tool for that. Dean often tells me when I'm wrong, by the way, and I appreciate that. That's a good thing. Okay. Any comments on that before we proceed? All right. Okay, so let's talk about data types and data structures, first of all. A data type. A data type is just a set of values and associated operations. That's all it is. It gives you information, but that's at its heart and soul, that's what it is. It's a set of values and associated operations. So when you say that you're going to make something an int, an integer data type, what are you doing? You're telling yourself and the computer what values are allowed in there. You're allowed to have 1, 2, 3, 4, 5. You're not allowed to have catfish or true, false. So you're setting up a set of values. And you're also setting up a set of operations, all of the standard math. I'm going to kill this. There we go. All right. So a set of values and associated operations. If you say something's Boolean, then you're saying the values are true, false, and the operations are and or not. They also do useful things, like they tell the computer how much memory space to set aside for a variable or an attribute. So an int is it still 4 bytes? 4 bytes. A double is 8 bytes or 16 bytes. So it's telling the computer how much space to set aside, how much memory to set aside. And then it's also saying how to interpret the data. So remember, everything, if you were just to look at the memory, all you see are zeros and ones. And how would you tell a sequence of zeros and ones that represents the letter A from the sequence of zeros and ones that represents the integer value 147, which I think is the ASCII value for A? And the answer is you can't. You need some kind of a tag to say, okay, this one is a letter of the alphabet and that one is an integer value. And that tag is what you're doing when you declare the attribute or the variable. Now, data types that we tend to think about are primitive, int, char, double. String is not primitive, but everybody treats it as if it was. They pretend that it is. Those of you that took C, I think, are really aware of that, because you explicitly made string an array of characters or an array of char. So those are the ones that are directly supported by the programming language. However, you can take those and compose more complex data types. So in databases, they talk about a record, like your record in Embry-Riddle's files might be your last name, your first name, your middle initial, date of birth, date that you entered the university, something like that. And that's considered one data type, student record, but it's composed of, last name is a string, first name is a string, middle initial is a char, date of birth is a date. So it's composed of all these other data types. And that's okay. Again, those of you that came from the C class, the struct is the thing that you're familiar with, where you can create your own data type by taking the primitive data types and lumping them together. Well, you're doing that in this class too. You're creating objects. You're creating classes. And what's an object or a class? Isn't it a set of attributes and then a set of methods? Oh, okay. So the attributes can be int xy, double, PQR. So now you've created a complex data type in your class. And you'll hear authors referring to classes as user-defined data types, because that's exactly what they are. You defined it. And really, it still meets that basic definition of set of values and associated operations. Because what did you do? You created attributes, those are the values, and you created methods, those are the operations. So that's a data type. Now what about a data structure? A data structure is how data gets organized in memory. It's the structure of the memory, the structure of the data. And it really only makes sense to talk about when we talk about multiple data values. So instead of having a single int, what if I had a whole bunch of them? You know, what if I had 1,000 of them? Well, I have options. I can put them in memory in different ways. The most straightforward, simple way to put them in memory is just one after the other, all in contiguous memory locations, one big memory block, 1,000 integers long. And when you do that, it's called an array. So an array is actually telling you in very clear terms how this thing is stored in memory. It's telling you that you have a bunch of data items and they're all in one block of memory, stored one after the other, after the other, after the other. Now, I'll make a note here. Modern programming languages tell you that they have an array and they behave like an array in terms of how you access them, but they're not. And I'll tell you immediately how you can tell. If you have an array that allows you to have a programming language that in your array, you're allowed to have different data types in the same array, I can promise you that they're telling you it's an array, but it's not technically an array. Now, from a user standpoint, you almost usually don't care. So I know in languages like JavaScript, you can create an array of items and you can put strings in one slot and you can put integers in another slot. And what that's telling me is JavaScript is not using an actual honest-to-gosh true array. And we can suss out why that is in a minute. Pausing for questions. Data types and data structures. Okay. The array elements. So an individual data value in the array is called an element of the array, and we access it using the index. That's usually put in square brackets. I don't know of any languages that doesn't use a square bracket for that. The head of the array is the name we give to the first element in the array. That's where that memory block, remember I said an array is, everything is stored in one contiguous memory block. The head is that first address of the first part of the memory block. We could also talk about the tail, which is the last one, but we normally just talk about the head. And really what happens, the computer typically only, quote, knows where the head is. And then how does it get to another element? Well, because every data element in a true array is the same data type, and we know how much memory each data type takes up, then basically what you can do is go to the head of the array and jump. So if you know that an integer is 4 bytes and you want to get to the third integer, you go to the head of the array and you jump 12 bytes. So if I were to say, I'm calling my array A, by the way. That's, whoa. Quit helping. I'm calling my array A. So, you know, great name, right? If I said A, and then in the square brackets I put a 3, what I'm saying is go to the front of the array and jump 3 integers and tell me what's there. Now, you have to use an integer value for those. You're not allowed to look at the 4th and a half element. There's no such thing. And you have to make sure that you're actually accessing something that's in the array. So if I said there's 5 elements in my array, I'm not allowed to go look at the 8th one. And again, those of you that took C, I think you know that you actually can. You can in some circumstances, and that's a huge security risk. All right, so we mentioned early on that in Java and many programming languages, the first element in the array is actually called A sub 0. Why is that? Because what you're saying is go to the head of the array and jump 0 spaces. That's why many programming languages start out with A sub 0. The languages that start out with 1, where they refer to the first element as 1, like MATLAB does, are generally languages that are language tools that they're hoping will receive a wider audience, people who are not generally computer scientists, software engineers, or have had years and years of experience programming. Because most people, once they have a few years under their belt of programming, they're very comfortable with the 0th element being the first, what the first element is called. Well, if we're going to start counting at 0 and we have 100 elements in the array and the first one is called 0, then the last one can't be 100 because that's 101, so it's going to be 99. So if I have, say, 3 elements in my array, their indices are 0, 1, and 2, not 0, 1, 2, 3. Be highly aware of that, because when you do your loops and you're looping through an array, it's very easy to ask for an additional element that you didn't intend to ask for. So be aware of that. And then you get an error, and the error is called index out of bounds. If you ever see an error called index out of bounds, what that means usually is you tried to reference an array element that is off the either end of the array. Either you had 100 elements and you tried to ask for the 150th, or it would be hard to do, but you may have asked for the -1 element, the -10th element. You get an array index out of bounds error. Okay, so in the general case, if we have n elements, it's from 0 to n minus 1. All right, now Java provides arrays as an object because it's an object-oriented language. So they provide arrays to you as objects. And this is a good thing because what it really means is there are attributes and methods associated with the object pre-built for you. And if you go to, I meant to have this up, if you go to the Oracle help page on arrays, you will find there's like 60 different methods that you can use on the array, including things like sorting, so you can automatically sort your elements, things like that. The most common attribute, though, that we're going to deal with is the length of the array. So inside the Java object, it keeps track of how many elements there are, which means you don't have to. You can always refer to the array.length attribute to remember, to know how big your array is. Now, because it's an object, we can declare the object, just like we did in a previous example. But how do you know when you actually get a new object? Let's go here. Here, I have these are the files for this module. I have a class called random data, and then I have random data controller because, again, I'm trying to show you always that objects, we don't create just one file. Objects talk to each other, and inside here I say random data, my data equals new random data, and here's my question to you: did I create a new object or not?
Yes.
You create.
Yes.
Yeah.
And there's a nice bright flashing flag that tells you why you're right? Why are you right? What is the keyword there that you're looking for?
New.
New. Now, had I done it like this, I'm going to screw this up, guys. Had I done it like this, where I declared this as an attribute, random data, my data, I can do that in here. All right. Now, in this line of code, did I create a new object?
No.
Because there's no new keyword. Did I declare, though? Did I declare my data to be anything?
Yes.
Yes. So there's a slight distinction between declaration and creation when we're dealing with objects. So I declared that I'm going to have, at some point, here's what I'm telling the computer. Hey, someday I'm going to make an object of this class and I'm going to call it my data. And then later on I make it. And it's the same thing with arrays. So you can declare the array without creating it. And that's actually a fairly normal thing to do. And the way you declare it is you use its data type. So here I'm making integers, and I just use the square brackets, but I leave them empty. We'll fix that later. So I leave those empty, and I say, okay, integer, square bracket, integer array. And now what I'm telling the computer is this. I haven't done it yet, but someday I'm going to create an array of integers. And when I do, I'm going to tell you how big it is. You've seen this already, public static void main string args. And that's what that's saying there, is it will accept an array of strings. Now to create the array, I use the new keyword, and I've always found this format a little disturbing. I'm just not thrilled with it. And then you use this formatting here. So integer array equals new. Now we're actually creating an array object, and we use this int square bracket, and then I'm going to say how big it is, 20. Or double, here's another array, new double 1000. So I'm using the data type square bracket. This is how big it is. I suspect they had to do that because you can create arrays of objects, and it would be confusion to the compiler if you were creating an object using the constructor, meaning parentheses, as opposed to creating the array of objects, which is the which would be the square brackets. So in here, I can actually create an object. So if I have a circle object and I wanted to create an array of them, and we did, circle object was one of the files we used in the first, I think the second module, right? One of the first files that we looked at. We create a circle object, and same trick. Its data type is circle object. So that's what you use in the, after the new keyword, circle object 15, and now I have 15 entities. Now, by the way, we'll talk about more about this when we get into objects. It's a little confusing. Here's what I have. I have an array of circle objects, but it's still empty because I didn't make my circles yet. So let me see if I can clarify that statement. When I say integer array equals new int 20, I have an array of 20 elements, each of which is an integer. Do they have any value yet? It's almost a trick question. Did I assign them values yet? What do you think? It's an array of integers. It's got spaces for 20 integers.
Didn't you say JavaScript autofills them as 0?
Yeah, Java will autofill them as 0.
Okay.
I don't have actually a real array of integers yet that's useful, right? You're right, exactly right. And that's why I said it's almost a trick question. It's a trick question in the sense that Java is going to fill those autofills with zeros. But in terms of useful data, no, I have not put the integer values that I want to use in there yet. And the same thing is here for the doubles. What it does is it fills up this array. It's got 1,000 spaces or 1,000 slots where I can put these values, but I don't have any of my real values in there yet. It's just all zeros. And the exact same thing happens here. I create my circle object, and I have space for 15 circle objects, but I didn't make any circles yet. For an object, the equivalent of 0 is called null. So what I've got is spaces for 15 circle objects, and all of them are null. I would have to go through and actually create those objects. So that's a slight distinction that will make sense. Many of you in your projects will have arrays of some kind of an object that you create, and some of you will say, hey, I made the array, and then I try to access the element, and I get this null pointer exception. And I'll say, yeah, because you never actually made the element inside the array. You made the array, which is like the house, right? It's like having a, I hope this is a good analogy. It's like building a stable for horses, and you've got 20 stables, but no horses, right? Until you put the horses in the stable, you don't have anything to work with yet. Is that a bad analogy? I don't know. Okay, so the basics to remember here. An array is a data structure where all the elements are stored in sequential memory locations. Because of that, when you access an individual array item, it's indices from 0 to n minus 1, not 1 to n, because of this go to the head and jump thing. And because an array is an object, you actually have to use the new keyword to actually get the array. Just because you get the array doesn't mean that you've got real usable data in there yet. You'll have to do something to put usable data in there. Read in a file or something. And again, guess what? You're going to use a for loop for that. And then lastly, because it's an object, you have access to the length by using array name dot length, and it will automatically tell you how many elements big it is. And we're going to use that in the for loops. So code is going to look like this. And I think I did this. I didn't save this file. I just wrote it and did this and trashed it. So here I say, okay, double example array. I have declared it. In other words, what I said to the computer is someday I'm going to create an array. I'm not going to tell you how big it is yet. And basically what the example array is doing, it's saying, okay, I'm going to keep some memory available, and when you tell me where this thing is, when you tell me where the head of this thing is, that's basically what I'm going to store there. It's a little more complicated than that, but what you're doing is you're reserving a spot to keep track of the head of the array. And then when you actually create the array object, so example array equals new double 100, now what happens? What does the computer do? It goes and finds 100 consecutive memory spaces that will fit the double. And it takes the head of that, the beginning memory location, and returns that back. And now example array says, okay, now I have an object. I know where the beginning of it is. I know where the head of this array is. And then for loops, which we talked about last week, and I said last week, we're going to do our stopping condition a little bit differently than we have been. So our loops now look like this. Again, almost all the time, because almost every time you use a for loop, you're going to go through an array. You're walking through an array and looking at the elements or doing something to each element. So your loops almost always look like this. And they look like this so often that you're going to forget that they don't have to look like this. So please don't forget that, even though, I don't know, 95% of the time they're going to look just like this. They're going to start out int I equals 0. Remember, I is the normal thing that we use for a counter in a loop to count how many times you've been through the loop. I equals 0. Now, why am I doing 0? Because I want to go to the first array element and its index is 0. So I equals 0. And then your stopping condition will almost always look like this. As long as I is less than array name dot length. So example array dot length. And that's where that length attribute is so useful. You can change the size of the array, and you don't have to mark it down somewhere else. You know, you're going to get that for free here. You don't know how big that array is before you started. You're going to get that for free here. So we say I equals 0. Now this is for the starting condition. The stopping condition, I is less than example array dot length, and then I plus plus. And again, that's why almost always you're going to use I plus plus, because you're just walking through an array. And then, by the way, I use random data a lot because of, you know, creating content is difficult. So I use random values quite a bit. I recommend those for testing, by the way, not formal testing, but when you're just getting your code to run and you just want to make sure that the parts actually talk to each other. Nothing wrong with random data. So, and then all I do is I set the ith element to a random value between 0 and 100. So that's how they look in code. Okay, so that's the distinction with arrays. Now the reason I threw methods in here is because once I have this notion of creating arrays, if we did everything inside of main, as you know, main gets ugly. So I'm trying to push this notion, this object-oriented notion of you should do your actual real work in methods. And so I didn't think the array would take up a full module, a full week of discussion. So I put the methods in this section also. So remember, classes are composed of attributes and methods, and attributes are the things that describe the object state, and methods modify that state. And a method is defined by the following items. You start out with visibility. Is it public or private? Almost always public. Is it static or non-static? If it's not main, don't make it static. The return type, int, double, boolean, string. You can even have a return type of an object that you've created or a class that you created. Many of your methods will not return anything, and the return type for that is void. And then the name of the method and the input parameters. The name and its input parameter list are called the method signature. I'm going to sometimes use this whole thing and call that the method signature, which works for the class, but is technically, someone who's really technically correct would ding me on that. So for example, public void foo int x int y. So public, everybody can see it. Void, it doesn't return a value. Foo, that's the name. And int x comma int y is telling you that it takes in two integer values, one of which we're going to call x and one of which we're going to call y. And x and y serve as local variables inside of the method. So that's just how you start to create them. And here's an example. Again, don't use static methods. Now, here's the trick though, and here's why people tend to use static methods, I believe. They say, I tried to call this method and I got an error that either said I was trying to, I got a null pointer exception, or I got this weird method that said that you're not allowed to use a non-static method in a static context. So I made the method static and everything worked. And what you did is you didn't fix the problem, you hid the problem. A non-static method means this. Remember, static meant that it never changes, it always exists. Public static void main. How do you start a program? This is the paradox, right? In order to start my program, I need to run main. In order to run main, I need to have an object of that class created to run main. Oh, that doesn't work. So how do I get around it? Static. Static means that that method exists even before the object was created. But if your methods are non-static, those methods really only exist after you create the object. And again, how do you know that you created the object? Somewhere there's a new keyword. So use non-static methods, and here's how you make it work. This is a typical, again, this is a useless bit of code that is there for just for example purposes. You make, I can't do this way. You make your attributes. Oh, I screwed up. Anyone see the screw up there in my attributes? I didn't make them private. Violated my own rule. Make your attributes and make them private. Now, all methods have access to all attributes. So if I want to do a method to initialize those attribute values, I just have to refer to the attribute by name. X equals 10, Y equals 15, Z equals 12. I don't have to do anything but refer to them by name. I can also refer to other methods. So if I'm going to do something really complicated and it's going to take, 100 lines of code, what I maybe should do is have a top-level method and break up that 100 lines of code into really small tasks, maybe 10 methods, each having 10 lines of code. And then my first method, all it does is say run method 1, run method 2, run method 3, run method 4, run method 5. And I give them good descriptive names, so if you're reading the thing, you can see what's happening. Method 1, method 2, method 3 are not descriptive names. So I make my attributes, and then my methods have access to those attributes. The method is almost always public. It's easier to have a rationale for a private method than a public attribute. All right. Then inside, here's main, right? So here's where the thing really runs. I can't use that method, initialize attributes, until I create an instance of the class, until I create an actual object from the class. And I cannot access int XYZ until I create an actual object from the class. So what's the first thing I do? Even though this is the class called method example, I'm allowed to create an object of myself inside the main method of the class. So I can say method example object equals new method example. And then its name is obj. Remember, that's my generic term when I just have to use an object, obj. So I'm going to pronounce that as object, even though it's obj. Object dot initialize attributes. Now I can access that method. And I access it using the normal dot notation, the name of the object dot the method that is in there. I can also access the attributes directly, object.x equals 0. I'm using that as an example. My recommendation, inside main, never access the attributes, because you're going to have methods that do that for you. Call the method. Now, how do students experience confusion when they first start to do this? One thing they might do is declare int XYZ inside of main. You declare XYZ inside of main. Now, who can guess what the problem with that is?
You can't access the attributes inside of the methods.
Exactly. So if I declare XYZ inside of main, I can only legally access them inside of main. But initialize attributes, this method out here, is not inside of main, so I wouldn't be able to access them. So again, make them attributes and all your methods can have access to them. Now I put a reminder in here that you would have setters and getters, so you would have a setter and getter for X, a setter and getter for Y, and a setter and getter for Z. But remember, a setter is one where a public usually a public method, where an external entity can set the value for those things, and a getter would be one that just returns the value. And it's normal to have those for every attribute or virtually every attribute. Okay, here's another use. So the idea here is inside of main, rather than doing your work inside of main, which is really not the object-oriented way to go. That's really an imperative paradigm. And again, old guys like me, we grew up in the imperative paradigm using Fortran and BASIC and those kinds of languages. And then when object-oriented came along, we just made one object and we put our whole old program inside of main and said, ta-da, now we're object-oriented. And of course, it was not true. So you create these are from the examples that we'll work with on Wednesday. You create these classes and you create all these methods inside this class that you're going to use, and then the class that uses it inside of main, I create an object of that class, and then I just start calling the methods from the other class. So instead of doing all that work inside main, what I'm doing is I'm doing all the work in other methods, and then I'm calling those methods. Now, in this case, those methods belong to another class. You can even do it within the same class. I will talk about that and recommend that when it's appropriate later in the course. So we have, random data equals new random data. Now I've got an object of that class. And random data has inside of it, look at right there, it's got an array of integers. So when I create the random data object from the random data class, I get an array of integers called data. Now, unfortunately, what I really got was just well, let me ask it this way. Did I get an array object? That's an important question. right? So I created the random data object. I know I did because I have the new keyword, and inside the random data object is this int array data, right? So I have an array of integers called data. Do I actually have that object yet or not? I'm not surprised that you're silent. This is the kind of thing you start to think through when you're programming that you maybe didn't have to think through before you started programming. Let me ask it this way. Where do you see the new keyword for the data array?
Under initialized data.
Right, so under initialized data. So until I run the initialized data method, I don't actually have an array object yet. Now, why would I do it that way? Why would I do this int data, which all I'm doing, remember, here's what I'm saying. I'm saying someday I'm going to create an array. I'm not going to tell you how big it is yet. And then down here, I actually create the array and with that size, with array size. Why would I do it that way? I do it that way so that random data, that class, can handle any size data object. And when I need one, I'll tell you how big it is. So over here, if you look, initialize data 14, I'm going to tell you, give me 14 data elements. So this is very versatile because I haven't nailed down a size. I haven't restricted the size. If I have a user that needs 14,000 data elements, this thing still works. If I have a user that needs 3, it still works. This is a cheap trick that you can do all the time. You just say, I'm going to keep track of, keep track of the head. I'm not going to actually create it until I know how big it is. Okay, so what's happening over here on the data controller? If you look what's happening, we say, okay, I initialize data, I print the data, I calculate the maximum, I calculate the minimum. If you name your methods what they do, it should be fairly straightforward for a human being to read through that and say, oh, I see what you're doing. You're creating random data, then you're initializing it, and then you're printing it out for some reason, and then you're going to calculate the maximum and calculate the minimum. So as a human being, you can read through that and see what's happening. If you didn't do it that way, if you tried to do the work in place, how would you tell the user what's happening? You would use comments. And so this is part of my constant advice is if you write really clear code, you shouldn't need comments. The comment block at the top of the code is the more crucial thing. And then within your code, if you're writing good code, you shouldn't need comments. Now, you might write temporary comments while you're building your code to remind yourself to do stuff, things like that. But hopefully you can look at what's happening here and have a good guess as to what's happening. Now, calculate maximum. What if you needed to know how that was done? Well, you go over to the calculate maximum method and look at how it's done. Now, I told you I used random data quite a bit, because when you're just doing example files in particular, random data is really helpful because it just gives you something to work with. So here's what I do. I create the actual array object, and somebody else told me how big it needs to be, and then there's my for loop. Man, doesn't that look familiar? That's going to look so familiar to you by the end of the semester. Int I equals 0, I is less than data.length, I plus plus, and all I do is I throw a random number. That's all. But notice each method does a small thing. Now, how do you know when to make these things? Now, this is actually something that's difficult in programming. No matter what programming paradigm you're working in, at some point you come across a really hard thing to do called solve the problem. So once you get to that part, then that's a difficulty. The generalized process, the most skeletal way to describe the process here is you think about what you want your software to do. And that's, you guys, by the way, the P1s that I'm looking at, most of you guys have a really good visualization of what you want this to do. Okay, you look at what you want the software to do. Then you start to break it up into, okay, in order to get this done, what objects do I need to create? And remember, back when we looked at the sheep-sheepdog game, oh, we need a sheep class, we need a dog class, we need a terrain class. You start playing that game of what classes or objects do I need? And then for each one, you say, what attributes do I need to describe that object? And that's usually all fairly straightforward, more or less. Then you get to the harder thing. What method should I create? Okay, now this is where you start thinking about, okay, let's go to the sheep-sheepdog game. I can create a sheep class, and the sheep class is going to be, you know, the attributes are easy enough. What attribute should I have? What is it going to do? What are people going to ask it to do? You might think of it as a service provider. You know, some objects are really well thought of as a service provider. If I were to open up this as a service to people, what would they ask me to do? What kinds of things? Now, each one of those things, when you answer each one of those, that's a method. So for the sheep, let's see. You need to tell me where you are. It needs to move every turn. So we're going to have a movement, some kind of a movement method, and we're going to have a method that says where we are, which would be normal for setters and getters anyway. And other than the move method, does the sheep really need to have any other actions? Maybe we wanted to make a noise, right? So we would have a vocalize method or something like that. But hopefully the sheep doesn't have an attack method. You know, you ask yourself those questions. Can the sheep jump over the fence? Is that part of the movement, or should I make a separate jump method? See, it starts to get hard. And quite frankly, you know, when you're doing real projects and real work, this question to the answer of what method should I have can be difficult. And then even where should that method go? That can be difficult too. But the basic process, think through the basic process and trust it. Think through what you want your software to do. Try to decide what classes or objects are needed to do that job. Create the attributes for them first, and then start asking yourself, what jobs will they be doing? What actions can they take? What functions do they serve? What services do they provide? That's when you know that you should be making a method. Now, of course, for every attribute, you should have a setter and getter. Virtually everyone. And it's, I can tell you this process, but you know, the only way you get good at it is by doing it over and over and over and over again. Okay, so I think it's the same slide, yeah, with that last. It can be difficult. It is difficult. There's rarely one right answer. At some point, it comes down to design differences. And it's okay to say, as you're going through and actually developing your code, it's okay to say, man, I thought I needed this method in this class, but maybe it really should be over here, and move it. That's fine. Or I thought I needed this method and I don't, or I didn't even know I needed this method and I do. That's fine. That's a normal part of developing your software. And then lastly, my process by which I do these things, I create I come up with an idea of what I want the software to do. The method I recommend is using user stories, and we'll talk about that more for the P2 deliverable. This is part of the Agile Scrum methodology. I come up with user stories. Each user story describes some functional aspect of the code. Then I create, again, my classes. I decide what my classes should be. I'm not programming anything. I'm designing them. I'm not programming. I say, okay, this class should have these attributes. This class should have these attributes. This class should have these attributes. And this class should have these attributes and methods. I get all that laid out, and so I know the names of all my attributes. I know the names of all my methods. I have a good idea as to what methods are going to be touching what attributes, and I know what my methods need as input. All of that is named. I effectively have all the signatures out there. But I don't have any method bodies. I haven't yet solved the problem of how it's done. I know I need to do this in this method. I don't know how. I don't need to know how yet. And then I'll create all of my code with empty methods, what I call empty methods. So if it's a method that doesn't return anything, all it does is it prints out, hey, somebody called me. I'm method so-and-so in class so-and-so, and somebody called me. If it's a method that returns a value, it returns a value like 0 or -1 or whatever. Or if it's a string, it says dummy message or something like that. Why do I do that? Now I've got all my code up and running. It's functional. It doesn't do anything, but it's functional. And if I need to now work on one part of my code, I know that the other parts of my code exist, so that if that part of my code that I'm working on needs to go get a value from another class, it can, even if it's a dummy value. Otherwise, if I try to build like all of just one class at a time, that doesn't make sense, because remember, all these objects are supposed to work together. So that's my methodology, and I keep strongly encouraging you to do that as you go through your project deliverables. So we'll be done in just a second. User stories in P2. Describe what your software is going to look like in P3. All your classes with the empty attributes, that's part of P4 with a couple of them that actually work. And then you take your user stories and you chunk them out into these little sprints. Every 2 weeks, I'm going to get 3 user stories done. And that's what your P4, 5, 6, and 7 are doing. So the way I've laid out the project fits this methodology. Okay, I'm going to take questions offline because I'm over time here and I know you guys got things to do. If you have questions, ask them Wednesday, or put them in the discussion board or send me a message in Canvas. And thank you for being here.